Hello everyone. Today we are going to talk about percentage change. Many a question coming in NEET are based on this. Listen to the lecture carefully. This will definitely help you to answer question better on the judgment day, that is your NEET examination day. So without wasting time, let's start with the topic of percentage change. Small topic but definitely useful to score more. So first thing is we will start with some questions. If x increases by following percentage, what do we finally have? If a quantity x increases by 10%, what do we finally get? So you will say if a quantity increases by 10%, you will finally have x plus 10% of x. Yes, that will be x plus 10x by 100, quite obvious. So that will be 110x by 100. So that will be nothing but 1.1x. So if a quantity increases by 10%, then its final value is 1.1 times the initial value. Let's see next example. If the quantity increases by 20%, what will you finally have? The same solution. You will say that the final value will be equals to initial value x plus 20% of x. X plus 20% of x is x plus 20x by 100. So that becomes 120x by 100. That is nothing but 1.2x. So if the quantity increases by 20%, it becomes 1.2 times. Next example. If the quantity increases by 35%, if the quantity increases by 35%, what will you finally have? So you will have x plus 35% of x. 35% of x means 35x by 100. That becomes 135x by 100. That becomes 1.35x. So what are you trying to do here? I'm trying to make you understand that as soon as you see in a question a quantity increases by 10%, you should be able to say, okay, it becomes 1.1 times. If a quantity increases by 20%, okay, it means it becomes 1.2 times. If a quantity increases by 35%, it becomes 1.35 times. So you should be able to answer this quickly. Let's practice a little more. If the quantity increases by 79%, then what will you finally have? So you will say that the final value will be x plus 79% of x. That will be x plus 79x by 100. That becomes 1.79x. So if a quantity increases by 79%, it becomes 1.79 times. Let's see more. What if the quantity increases by 125%? If a quantity increases by 125%, its final value will be x plus 125x by 100. That becomes 225x by 100, which is nothing but 2.25x. So an increase of 125% means that the quantity becomes 2.25 times. You should be able to do this really quickly as soon as you see in a question. Let's move on. What if the quantity changes by minus 20%? When I say that the quantity changes by minus 20%, it means that the quantity is decreasing by 20%. So you will say that the final value is x minus 20x by 100. It is decreasing by 20%. So the final value will be 0.8x, x minus 20x by 100 gives you 80x by 100, and that becomes equals to 0.8x. So if a quantity decreases by 20%, it becomes 0.8 times. Let's see one more example. If a quantity decreases by 60%, what will you finally have? So you will again say it will become x minus 60x by 100. X minus 60x by 100 gives you nothing but 40x by 100. So sir, 40x by 100 is nothing but 0.4x. So you should be able to see these things really quickly. So if the quantity decreases by 20%, it becomes 0.8 times. If the quantity decreases by 60%, it becomes 0.4 times. If a quantity decreases by 10%, it becomes 0.9 times. So you should be able to say these things really quickly. Moving on. Find the percentage change in x when x changes from x to 1.5x. You should be able to answer the reverse question. If a quantity x becomes 1.5 times, then what is the percentage change? So we know that percentage change is given by final minus initial upon initial into 100. So here you will write final value 1.5x minus initial value x upon initial value x into 100. So that will be nothing but 50%. So this is kind of the reverse question. If a quantity becomes 1.5 times, what is the percentage change? So you should be able to answer that the quantity increases by 50%. Next. If the quantity changes from x and becomes 0.8x, see the quantity is decreasing. It has changed from x and became 0.8x. Then what is the percentage change? Now you will say, so one thing is for sure, if the quantity decreases, then the percentage change has to be negative. So if the quantity changes from x and becomes 0.8x, then the percentage change will be given by final minus initial upon initial into 100. That will be equals to 0.8x minus x upon x into 100. 0.8x minus x. In the numerator, you will get minus 0.2x upon x into 100. So that becomes minus 20%. It means that the quantity decreases by 20%. Let's see one more example. If the quantity changes from x and become root 2 times, if a quantity becomes root 2 times, what is the percentage change? We know that we can write root 2 as 1.414 or approximately as 1.4. So let's see. If the quantity changes from x and becomes root 2 times, what is the percentage change? Again, you will say final minus initial upon initial into 100. That will be 1.414x minus x upon x into 100. 1.414x minus x gives you 0.414x by x into 100. So that is nothing but 41.4%. So this is the percentage change in the quantity. Let's see more examples. Let's say a quantity changes from x and becomes 3x. If the quantity becomes 3 times, what is the percentage increase? You will say that the percentage change will be final minus initial upon initial into 100. So that will be 3x minus x upon x into 100. 3x minus x, the numerator becomes 2x upon x into 100. So the xx get cancelled. What you get is 200% increase. If the quantity becomes 3 times, the percentage increases 200%. Okay? You should be able to do these things really quickly. Moving on. If the quantity changes from x and becomes root 3x, what is the percentage change? Again, the same percentage change will be final minus initial upon initial into 100. You can write root 3x as 1.73x, approximately equal to. So what you get is root 3x minus x upon x into 100. That becomes 1.73x minus x upon x into 100. So that is nothing but 0.73x upon x into 100, which is 73% increase. Okay. So if a quantity becomes root 3 times, the percentage increase in the quantity is 73%. Let's take one more example. If the quantity changes from x and becomes 2.25x, what is the percentage increase? So now again you will say, sir, percentage change has to be final minus initial upon initial into 100. That is 2.25x minus x upon x into 100. 2.25x minus x gives you 1.25x upon x into 100. That is nothing but an increase of 1.25 into 100. That is 125%. So let's practice some questions based on these concepts. Let's see this question. If power dissipated by a resistor equals to the current flowing through the resistor whole square into its resistance, then to double the power dissipated by the resistor, the current should increase by a dash percentage. So power dissipated by resistor equals to I square R. Then to double the power dissipated, the current should increase by how many percentage? And these type of questions do come in competitive examination very commonly. So you should be able to answer them without even raising pen. Let's see how. You will say, so first thing I can see is power is proportional to I square. Yes, sir. Power is not directly proportional to I. Power is proportional to I square. So if the current becomes double, power becomes double square times. That is 4 times. If the current becomes triple, power dissipated becomes 3 square times. That is 9 times. If the current flowing becomes 10 times, then the power dissipated becomes 10 square times, that is 100 times. This is the meaning of power proportional to I square. So you can say, sir, if current become n times, then the power dissipated will become n square times. Very right. So you have to think on these lines. So what is the question asking me? To double the power dissipated, the current should increase by dash percentage. So you will say, when current becomes n times, the power dissipated becomes n square times. Here we want the power dissipated to be double. As we want the power dissipated to be double, we can say that n square should be equal to 2. If n square equals to 2, it means that n is root 2. So do understand, for power dissipated to become double, current should actually become root 2 times, so that the power dissipated become root 2 whole square times, which is 2 times. So, for the power dissipated to become double, the current should become root 2 times. If the current has to become root 2 times, what is the percentage increase in current? So, let's see. Hence, the current should become root 2 times. Say, from I0 to root 2 I0. Let's say the initial current was I0 and the new current is root 2 I0. If the current becomes root 2 times, what is the percentage increase in current? So you will say the percentage change in current has to be equals to final minus initial upon initial into 100. You can write root 2 as 1.414. So what you get here is 1.414 I naught minus I naught by I naught into 100. That is nothing but 41% increase. Yeah, you can say 41.4% increase, but 41% increase nearly. That is the answer. Let's see next question. If the force between two charges is given by k q1 q2 by r square, find the percentage change in r for the force to become 1/4. You want the force to become 1/4. What has to be the percentage change in r? So here we can see clearly that force is proportional to 1 by r square. Yes, sir. Sir, as force is proportional to 1 by r square, if r becomes double, force becomes 1 by 2 square times, that is 1 by 4 times. If r becomes triple, force become 1 by 3 square times, that is 1 by 9 times. If r become 10 times, force becomes 1 by 10 square times, that is 1 by 100 times. So I can say for sure, if r become n times, the force becomes 1 by n square times, as force is proportional to 1 by r square. As per the problem statement, you want the force to become 1/4. Yes, sir. If you want the force to become 1/4, and when r becomes n times, force becomes 1 by n square times. So you can say that 1 by n square should be equal to 1 by 4. If 1 by n square equals to 1 by 4, then you get that n should be equal to 2. So for the force to become 1/4, r should become double. For the force to become 1/4, r should become double. And for r to become double, what is the percentage increase in r? You will say, so let's say the separation changes from r naught and becomes 2r naught. R becomes double. When the separation changes from r naught and become 2r naught, r becomes double. What is the percentage increase? You will say, sir, the percentage change equals to final minus initial upon initial into 100. 2r naught minus r naught upon r naught into 100. That gives you r naught by r naught into 100, which is nothing but 100% increase in separation. Let's move on further. The kinetic energy of a particle is given by half times its mass times its speed whole square. Determine the percentage change in kinetic energy if the speed increases by 20%. So when the speed increases by 20%, what is the percentage change in kinetic energy? How do I personally solve this question? I personally do it this way. See, kinetic energy equals to half mv square. Speed increasing by 20%. So if the initial speed is v, final speed will be 1.2 v. Kinetic energy proportional to v square. I do not write, I think all of this in my head. So when the speed becomes 1.2 times, kinetic energy which is proportional to v square will become 1.2 whole square time, that will be 1.44 times. If the final kinetic energy is 1.44 times the initial kinetic energy, if the final kinetic energy is 1.44 times the initial kinetic energy, the percentage increase in kinetic energy is 44%. This is how we roll. But let's do it slowly because we are learning. So, assuming the initial speed to be v naught, we will say if the speed increases by 20%, the final speed will be initial plus 20% of v naught. So the final speed will be v naught plus 20 v naught by 100. So the final speed will be 1.2 v naught. We know that kinetic energy is proportional to speed square. So when the speed changes from v naught and become 1.2 v naught, how many times the kinetic energy will become? So you will say, sir, kinetic energy is proportional to v square. When the speed becomes n times, the kinetic energy will become n square times. Just like we learned for power and current. Power proportional to I square. When current becomes n times, power dissipated becomes n square times. Here when speed becomes n times, kinetic energy becomes n square times. So what you say further is, hence the final kinetic energy will be equal to 1.2 square times the initial kinetic energy. And the speed becomes 1.2 times, kinetic energy becomes 1.2 square times. Hence, the final kinetic energy equals to 1.44 times the initial kinetic energy. What is the percentage change in kinetic energy? You will say the percentage change in kinetic energy equals to kinetic energy final minus kinetic energy initial upon kinetic energy initial into 100. kinetic energy final can be written as 1.44 times kinetic energy initial. So that will be 1.44 times kinetic energy initial minus kinetic energy initial upon kinetic energy initial into 100. That becomes nothing but 44%. But I want you guys to answer all these questions orally rather than solving them using a pen and paper. Let's move on. Time period of a simple pendulum equals to 2 pi under root of length of the spring by g. Determine the percentage change in length of pendulum for which the time period increases by 30%. So what has to be the percentage change in the length of pendulum if you want the time period to increase by 30%? So you will say, dekh bhai, time period should increase by 30% and time period is proportional to root L. So if time period is proportional to root L, if length becomes n times, time period becomes how many times? Think of it as time period proportional to root L as time period proportional to L raised to the power of half. So if L becomes double, time period becomes root 2 times. L becomes triple, time period becomes root 3 times. L becomes n times, time period becomes n raised to the power of half times. And that's the same statement written here. If the length becomes n times, the time period becomes root n times, that is n raised to the power of half times. So if the length becomes n times, time period becomes root n times. You want the time period should increase by 30%. Now, as the time period increases by 30%, the final time period will be equals to initial time period plus 30% of initial time period. So that will be equals to initial time period plus 30 by 100 times initial time period. That will be 1.3 times the initial time period. So you should be able to get this without raising pen. Okay, you want the time period to increase by 30%. So the final time period will be 1.3 times the initial time period. So you want the final time period to be 1.3 times the initial. You need to find the percentage change in length. If the time period should increase by 30% or become 1.3 times, then the length should become how many times? So you will say, as the time period, when the length becomes n times, time period becomes root n times. You want the time period to become 1.3 times. So it means that root n or n raised to the power of half equals to 1.3. If n raised to the power of half equals to 1.3, what is n? So sir, n will be equals to 1.3 square. So 1.3 square is 1.69. So for the time period to become 1.3 times, that is increased by 30%, the length should become 1.3 square times. The length should become 1.69 times. So you will say, for the time period to increase by 30%, that is for the time period to become 1.3 times, length should become 1.69 times. Now, since you know the length final should be 1.69 times the length initial, what is the percentage increase in length required? You will say the length final is 1.69 times the length initial. So the percentage change in length equals to final minus initial upon initial into 100. That is 1.6 times 69 times initial length minus initial length upon initial length into 100. That becomes 69%. So the length should increase by 69%. Moving on. So, keeping the volume of a wire constant, if the length is increased by 25%, find the percentage change in cross-sectional area. So you are keeping the volume of the wire constant and you are increasing the length by 25%. What is the percentage change in the cross-sectional area? So let's say you have this wire. Let's say the cross-sectional area is A and length is L. You know that you can write the volume of this wire as cross-sectional area times length. As per the problem statement, the volume is constant. Yes, sir. If the volume is constant, then what can we say to be the relationship between A and L? We can say that if volume is constant, then the cross-sectional area is inversely proportional to length. Cross-sectional area is inversely proportional to length. It means that when length becomes double, cross-sectional area becomes half. Length becomes triple, cross-sectional area becomes 1/3. Length becomes 10 times, cross-sectional area becomes 1 by 10 times. That is the basic idea. So now here, as the length becomes n times, cross-sectional area becomes 1 by n times. So that is the meaning of being inversely proportional. Now here, the length is increasing by 25%. So 25% increase in length means the final length will be initial length plus 25% of initial length. That will be equals to initial length plus 25 by 100 times initial length. That will be equals to 1.25 times initial length. If the length becomes 1.25 times, then how many times the cross-sectional area will become? Remember that cross-sectional area is inversely proportional to length. So when the length becomes 1.25 times, cross-sectional area changes from initial cross-sectional area A and becomes A upon 1.25. If length becomes n times, cross-sectional area becomes 1 by n times, given that the volume is constant. So moving on here, so as the length becomes 1.25 times, you will say that the cross-sectional area becomes 1 upon 1.25 times. As the cross-sectional area becomes 1 upon 1.25 times, you can say that the final cross-sectional area equals to initial cross-sectional area divided by 1.25. Now, 1.25 is nothing but 5 by 4, just telling you. Okay. So, you can write this as the final area equals to initial area upon 5 by 4. So, that becomes 4 by 5 times the initial area. So now you know that final area is 4 by 5 times initial area. Question done. What is the percentage change in area? You will say that the percentage change equals to final minus initial upon initial into 100. Final minus initial upon initial into 100. In place of final, substitute 4 by 5 of initial. So you get 4 by 5 AI into initial area upon initial area into 100. 4 by 5 minus 1 becomes minus 1 by 5. And AI get cancelled. So you get minus 1 by 5 into 100. That is nothing but minus 20%. So it means that when the length increases by 25%, the cross-sectional area decreases by 20%. Moving on. Force equals to K Q1 Q2 upon R square, the standard Coulomb's law. If one of the charge is doubled, determine the required percentage increase in R to keep force the same. One more time. F equals to K Q1 Q2 upon R square. If one of the charge is double, what has to be the percentage increase in separation between the charges so that the force remains the same? So let's say bachcho, here, if charge becomes K times and separation becomes N times, force will become how many times? If charge becomes K times and separation becomes N times, force becomes how many times? Do not confuse this K with the K of the Coulomb's law. This is what we are saying. If the charge becomes K times and separation becomes N times, the force becomes how many times? So let's see. We know that the force is proportional to charge upon R square. Yes, sir. So if charge becomes K times and separation becomes N times, the force becomes how many times? If charge becomes K times and separation becomes N times, the force becomes K upon N square times. Why? Because force is directly proportional to charge and force is inversely proportional to the whole square of separation. So if charge becomes K times and separation becomes N times, the force becomes K upon N square times. Now, you want here the force to remain same. Hence, you can say that the value of K upon N square should be 1. When charge becomes K times, separation becomes N times. The force becomes K upon N square times. You want the force to be same. So the final force is same as initial force. So it should become how many times? If the final force is same as initial force, it should become 1 time. So hence you will say K upon N square is 1. They have given you in question that K is 2. Then what has to be the value of N so that the force remains the same? So you will say K upon N square should be 1. And they have told me that the charge becomes double. So 2 upon N square should be equal to 1. As 2 upon N square should be equals to 1, you can say that N has to be equals to root 2. So on doubling one of the charge, if you want the force to be same, the separation should become root 2 times. Once you know that separation should become root 2 times, you already know what is going to be the answer of percentage increase in separation. So as the separation should become root 2 times, you will say that hence the separation should become root 2 times. So let's say the initial separation is R0 and final separation is root 2 R0. So the percentage change in separation equals to final minus initial upon initial into 100, that is root 2 R0 minus R0 upon R0 into 100, that becomes 41%. In place of root 2, substitute 1.414. So the separation should increase nearly by 41%. Till now, we have talked about large changes, 10%, 20%, 30%. Now we will talk about small changes like 1%, 0.5%, 2%. So if you have got small changes, what to do? Let's say there is a quantity Z which depend upon other quantity A, B and C as per Z equals to a constant times A raised to power of alpha, B raised to power of beta upon C raised to power of gamma. Taking natural log both the side, you will say ln z equals to ln of k a raised to power of alpha b raised to power of beta upon c raised to power of gamma. Now, using the property of log, I am going to write something. Which property? Ln ab equals to ln a plus ln b, and ln a by b equals to ln a minus ln b. So I can write this quantity k a raised to power of alpha b raised to power of beta upon c raised to power of gamma as ln z equals to ln k into ln a raised to power of alpha plus ln b raised to power of beta minus ln c raised to power of gamma. Now I'm going to use another property of log. If you have got ln x raised to power of n, that can be written as n ln x. It means that you can bring the power in front. So here you can take the alpha in front, you can take the beta in front, you can take the gamma in front, and you get ln z equals to ln k plus alpha ln a plus beta ln b minus gamma ln c. These are small properties of log that you should know. Now, differentiating out each term, we will say that differentiation of ln z equals to differentiation of ln k. What is the differentiation of any constant? So since k is a constant, ln k is also a constant, and differentiation of any constant is 0. So what is the differentiation of ln z? Differentiation of ln x is equals to 1 by x dx. So sir, what will be the differentiation of ln z? Differentiation of ln z will be 1 by z dz. Differentiation of ln a 1 by a dA. Differentiation of ln b 1 by b db. Differentiation of ln c 1 by c dc. If you have doubt over this, do wait for the video of differentiation to come up. That will be coming up in the next hours. So now differentiating out each term, we get differentiation of ln z equals to dz by z equals to differentiation of k, that is 0, plus alpha times differentiation of ln a, that is dA by a, plus beta times differentiation of ln b, that is db by b, minus gamma times differentiation of ln c, which is dc by c. Now what does dz represent? Dz represents infinitely small change in z. What does dA represents? Infinitely small change in a, db infinitely small change in b, dc infinitely small change in c. Now what we are going to do is an approximation. We are going to approximate these infinitely small changes to small changes. So for small changes approximating, we get that delta z by z, given that delta z is small. Delta z by z, what is delta z by z? The fractional change in the value of z equals to, you don't need to write 0, alpha delta a by a plus beta delta b by b plus minus gamma delta c by c. So all you need to remember is these two things. First, if a quantity z depends upon a, b and c as a constant times a raised to power of alpha, b raised to power of beta upon c raised to power of gamma, then for small changes you can write delta z by z equals to alpha delta a by a plus beta delta b by b minus gamma delta c by c. Let's talk a little bit more on this. We have learned that the fractional change in z equals to alpha times fractional change in a plus beta times fractional change in b minus gamma times fractional change in c. If the quantity increases, then the fractional change is positive, right? If a quantity increases, then the fractional change is positive because the final value will be more than initial value and delta z will be positive. If a quantity decreases, then the fractional change is negative, because we say that delta z is z final minus z initial. If the quantity decreases, then z final will be less than z initial. If z final will be less than z initial, then delta z will be negative. Next, one should use this formula only for small changes. This formula doesn't work for change of 25%, 20%. You should use it for small changes, 1%, 0.5%, 2%. Now let's practice out some question to understand this thing better. The question is, time period of simple pendulum is given by 2 pi under root L by G. If the length increases by 1%, and G decreases by 0.5%, the percentage change in time period is. So length is increasing by 1% and G is decreasing by 0.5%. They're asking you what is the percentage change in time period. Sir, here time period equals to 2 pi under root L by G. I can write it as L raised to power of half upon G raised to power of half. So this 2 pi is just like K. How to write relationship? We have learned that if we have a quantity z equals to k a raised to the power of alpha b raised to the power of beta upon c raised to the power of gamma, then delta z by z equals to alpha delta a by a plus beta delta b by b minus gamma delta c by c. Some of you watching this video might be feeling, sir, you're writing the minus wrong. You're writing the minus wrong. It should be plus. No, beta. That is for small errors that we will do again in the later hours. Right now, we are doing percentage change. For percentage change, you keep this minus as minus. Do not worry on that. Okay, so now you will say time period equals to 2 pi under root L by G. So 2 pi L raised to the power of half G raised to the power. How to write this thing? So you will say delta T by T equals to half delta L by L minus half delta G by G. If you can write this, you can do all questions easily of small percentage change, and they are very easy. So let's see. Time period is 2 pi under root L by G. Yes, sir. So I can write delta T by T equals to half delta L by L minus half delta G by G. Yes, sir. If I multiply each term with 100, what is delta T by T? Sir, fractional change in time period. What is delta T by T into 100? Sir, percentage change in time period. What is delta L by L? Sir, fractional change in length. What is delta L by L into 100? Sir, percentage change in length. So here you get the percentage change in time period equals to half times percentage change in length minus half times percentage change in G. Now the length is increased by 1%. If the length is increased by 1%, what is the percentage change in length? You will say, sir, the percentage change in length is plus 1. G is decreased by 0.5%. Decreased by 0.5%. If a quantity decreases, then the percentage change should be taken as negative. So the percentage change in G shouldn't be substituted as plus 0.5. It should be substituted as minus 0.5. So you get the percentage change in time period equals to half times of plus 1 because length increases by 1% minus half times of minus 0.05. Now 1 into half gives you half. Minus minus becomes plus. This is half and 0.5 is also half beta. So half into half becomes 1 by 4. Hence what you get is 3 by 4%. That is 0.75%. Okay. Let's try out next problem. If the mass of a cube increases by 1% and side length increases by 0.5%, find the percentage change in density. So mass of cube increasing by 1% and the side length is also increasing but by 0.5%. What is the percentage change in density? So you will say for a cube of mass m and side length a, we know that for anything density equals to mass by volume. So even for this cube, you can say density equals to mass upon volume. And the volume of a cube is nothing but the side length whole cube. So if a cube has side length A, then its volume equals to A cube. So you will say the density of cube equals to its mass upon its volume. Looking at this, rho equals to m by A cube. How can you write the relationship between rho, m and A for small changes? So you will write delta rho by rho equals to delta m by m minus 3 delta A by A. So you will get delta rho by rho equals to delta m by m minus 3 delta A by A. The power comes in front. If it's in denominator, you place a minus sign. If it's in numerator, you place a plus sign. Now multiplying each term with 100, you get delta rho by rho into 100 equals to delta m by m into 100 minus 3 delta A by A into 100. What is delta rho by rho into 100? Percentage change in density, percentage change in mass, and this quantity is percentage change in side length. In the question, they have said that the mass increases by 1%. So here I should substitute plus 1 or minus 1. So if the quantity increases, the percentage change is positive. So sir, here you should substitute plus 1. And the side length increases by 0.5%. So what should I write? Delta A by A into 100. Should I write plus 0.5 or minus 0.5? So as the side length increases, you should write plus 0.5. So what you get is the fractional percentage change in density equals to plus 1 minus 3 into plus 0.5. So that becomes 1 minus 1.5, which is minus 0.5%. It means that the density decreases by 0.5%. The minus sign tells you that the density doesn't increase. The density decreases by 0.5%. Let's see next example. The negative sign here represents that density decreases by 0.5%. So next example, F equals to gm1 m2 upon r square. This is the force between two masses m1 m2 separated by distance r. If both the masses are increased by 1% and the separation between the masses decreases by 1%, find the percentage change in force. So both the masses are increasing by 1% and separation between the masses is decreasing by 1%. We need to find the percentage change in the force. So you will say F equals to gm1 m2 upon r square. Yes, sir. So delta F by F equals to delta m1 by m1 plus delta m2 by m2 minus 2 delta r by r. It's in denominator, so you must place a minus sign and the power in front too. Now multiplying each term with 100, you will write delta F by F into 100 equals to delta m1 by m1 into 100 plus delta m2 by m2 into 100 minus 2 delta r by r into 100. Delta F by F into 100 represents percentage change in force. This quantity delta m1 by m1 into 100 represents the percentage change in mass. Now as per the problem, both the masses are increasing by 1%. If they are increasing by 1%, you will substitute delta m1 by m1 into 100 as plus 1. Similarly, delta m2 by m2 into 100 as plus 1. And the separation between them decreases by 1%. So you will write delta r by r into 100 as minus 1. So what you get is percentage change in force equals to plus 1 for this, plus 1 for this, minus 2 from here, and in place of delta r by r into 100, you again substitute a minus 1 because it decreases by 1%. So what you get is plus 1 minus of minus minus of minus. This becomes plus, so you get 2 plus 2, that is 4%. Hence, the force increases by 4%. Why? Because we know here we have a plus sign. So the last example for small percentage change is here. For a given wire, the resistance is related to length and radius as R equals to rho L by pi r square. Keeping the volume of wire constant, if the radius of wire is decreased by 1%, find the percentage change in resistance. Once more, for a wire, the resistance is related to length and radius as R equals to rho L by pi r square. Keeping the volume of wire constant, if the radius of the wire is decreased by 1%, find the percentage change in resistance. So again here the volume is constant. We know that the volume of wire will be given by pi r square into L. If you have this wire of radius r and having a length L, then the volume of wire will be pi r square into L. Now here in the question they have said that the volume is constant. Using the same expression which we learned that if z equals to k a raised to power of alpha b raised to power of beta upon c raised to power of gamma, we can write delta z by z equals to alpha delta a by a plus beta delta b by b minus gamma delta c by c. We get that delta v by v equals to 2 delta r by r plus delta l by l. As per the problem statement, volume is constant. So what will be the value of delta v? So delta v will be 0. So as delta v will be 0, you will say minus 2 delta r by r equals to delta l by l. Take this quantity to left hand side as delta v is 0. There is no change in volume. So you know what is the relationship between change in radius of wire and change in length of wire. Moreover, you know that resistance equals to rho L by pi r square. So as resistance equals to rho L by pi r square, you can say that delta r by r equals to delta L by L minus 2 delta r by r. Here capital R is resistance and small r is radius of the wire. In the question, they have said that the radius of the wire is decreased by 1%. They have not commented on length at all. But you know that since the volume is constant, the relationship between change in length and change in radius will be given by this. So you can say that the fractional change in length equals to minus 2 times the fractional change in radius. Substituting it, we get that the fractional change in resistance equals to minus 2 delta r by r minus 2 delta r by r, that becomes minus 4 delta r by r. Multiplying both the side with 100, we get the percentage change in resistance equals to minus 4 times the percentage change in radius, which is -1. So why you substituted -1? Because beta, the radius is decreasing by 1%. So you get -4 times -1, that becomes equals to 4%. Plus 4 sign here represents that the resistance increases by 4%. So that's all in changes large and small. Now we are going to talk about basic graphs, followed by a discussion on binomial approximation, and then we will talk about straight line. So first thing first, let's start talking about basic graphs. When I say that we are going to discuss basic graphs, I do not mean that we are going to discuss the graph of parabola, ellipse or hyperbola. What we are going to discuss are the type of graphs which are most commonly used in physics, and those are the graph of y proportional to x raised to power of n. Now there are multiple cases that we need to see here. Let's start breaking them down one by one. Let's say in some type of proportionality, the choice of n is 1. When I say that n is 1, here in place of n, just substitute 1. What do you get? You get that y proportional to x. When you have y proportional to x, it means that when x becomes double, y becomes double. X becomes triple, y becomes triple. X becomes 10 times, y becomes 10 times. This is the meaning of being directly proportional. So, for n equals to 1, if we think of the xy graph, what do we get? We get a straight line passing through the origin. Now, let's think of another case. What if n is greater than 1? If n is greater than 1, let's say n is 2 or n is 3. So if we substitute here n equals to 2 or 3, we get that y proportional to x square or y proportional to x cube. To understand, let's first talk about y proportional to x square. If y is proportional to x square, when x becomes double, y becomes 4 times. When x becomes triple, y becomes 3 square times, that is 9 times. When x becomes 10 times, y becomes 10 square times, that is 100 times. Similarly, if you have y proportional to x cube, when x becomes double, y becomes 2 cube times, that is 8 times. When x becomes triple, y becomes 3 cube times, that is 27 times. When x becomes 10 times, y becomes 10 cube times, that is 1000 times. So this is the meaning of y being proportional to x square or y being proportional to x. Now, if we think of this y proportional to x square, let's say, which quantity grows faster, x or y? So when x becomes double, y becomes 4 times, x becomes triple, y becomes 9 times, x becomes 10 times, y becomes 100 times. So which quantity grows faster? So we can see that y increases at a faster rate than x. If y increases at a faster rate than x, then how will the xy graph will look like? So the xy graph looks like this. Sir, why this? Why not straight line or why not this? See here. Here, as x increases, no doubt y increases. But we know that y increases at a faster rate. So for the small change in x, the amount of change in y should be more. Hence, the graph is curved upwards. The change in y is faster than the change in x. Let's see for the other cases. What is the graph of y proportional to x raised to power of n for n ranging between 0 and 1? N ranging between 0 and 1 means n is half or 1 by 3 or 1 by 4. To understand, let's take the case when n is half. If n is half and you have got y proportional to x raised to power of half, by squaring both the sides, you get y square proportional to x. If you have got y square proportional to x, it means that when y becomes double, x becomes 4 times. When y becomes triple, x becomes 9 times, because x is proportional to y square. So definitely, as x increases, y increases. X increases from 4 times to 9 times, y increases from 2 times to 3 times. As x increases, y increases, but in this case, x increases faster than y. So as x increases, y increases, but x increases at a faster rate. As x increases at a faster rate compared to y, how will the xy graph will look like? Sir, x has to increase at a faster rate than y. If I write like this, then both of them are directly proportional. But we know that x has to increase at a faster rate. So the graph goes something like this. Here you can see that as y increases, x increases, but the change in x is more for a given change in y. X increases at a faster rate than y. Now let's think of next case. What if n is 0? When I say that n is 0, it means that y proportional to x raised to the power of 0. So anything raised to the power of 0 is 1. So when I say y proportional to x raised to the power of 0, it means that y is independent of x, doesn't depend upon x. So if n is 0, it means that y is independent of x. When I say that y is independent of x, what I mean is on changing x, the quantity y won't change. So if on changing x, the quantity y won't change, what will the graph look like? Y remains constant. X keeps on increasing, but the y remains the same. The last case. What if n is less than 0? What if n is a negative number? Let's think of a negative number. Let's say n is minus 1. So we get y proportional to x raised to the power of minus 1. When we have got y proportional to x raised to the power of minus 1, we can say y proportional to 1 by x. So when x becomes double, y becomes half. X becomes triple, y becomes 1/3. X becomes 10 times, y becomes 1 by 10 times. Let's think of another case. For n less than 0, let's say n is minus 2. If n is minus 2, then we will say y proportional to x raised to the power of minus 2. So y proportional to 1 by x square. So now when x becomes double, y becomes 1/4. X becomes triple, y becomes 1/9. X becomes 10 times, y becomes 1 by 100 times. So here we can see one thing. If n is less than 0 now, then with the increase in x, y decreases. So if n is less than 0, let's say the case like y proportional to 1 by x square or y proportional to 1 by x cube. Y decreases as x increases. For y proportional to 1 by x square, as x becomes double, y becomes 1/4. X becomes triple, y becomes 1/9. So if we think of the xy graph, as x increases, y decreases. How will the graph look like? So we say that the graph of x versus y looks like this. As x increases, the value of y keeps on decreasing. As for example, you have got, let's say, y proportional to 1 by x square. As x tends to 0, y tends to infinity. So you can see that in the graph right here, as x tends to 0, the quantity y tends to be infinite. Okay, so now let's see some usage of what I have taught just now. First case, we know that from Ohm's law, the potential drop across a resistor equals to the current flowing through it times its resistance. So we know that the potential drop is directly proportional to current. If we need to draw the potential drop versus the current diagram, what we will get? As we know that V is directly proportional to I, the graph is nothing but a straight line passing through the origin. Let's think of another case. We know that the power dissipated by a resistor equals to current flowing through the resistor whole square I square times its resistance. So we can say that the power dissipated by a resistor is directly proportional to the whole square of the current flowing through it. Now what will the graph of power versus current will look like? So we know that power proportional to I square. So when current becomes double, power becomes 4 times. Current becomes triple, power becomes 9 times, given that we are talking about the same resistance. So what will the graph look like? The graph has to be straight line? No, that is for direct proportionality. The graph has to be like this. This is the graph when current grows faster than power. Or the graph has to be like this. This is the graph when power grows faster than current. Here we know that when current becomes double, power becomes 4 times. So power grows faster than current, hence the graph goes like this. Let's see more application. The electric field produced by a charge q at distance r is given by kq by r square. What is the graph of E versus r? So first thing first, electric field produced by charge is inversely proportional to the whole square of the distance from the charge. So E proportional to 1 by r square. R becomes double, E becomes 1/4. R becomes triple, E becomes 1/9. R becomes 10 times, the field intensity becomes 1 by 100 times. So what will be the graph of E versus R? So as R increases, electric field intensity keeps on decreasing. When R approaches 0, electric field intensity is kind of infinite, and when R becomes infinite, electric field intensity kind of becomes 0. So this is the graph for E equals to kq by r square. Next, time period of simple pendulum is given by 2 pi under root L by G. So we can say that time period is proportional to root L. Here is the example when n lies between 0 and 1. So time period is proportional to root L. So when L becomes double, time period becomes root 2 times. L becomes triple, time period becomes root 3 times. L becomes 4 times, time period becomes root 4 times, that is double. L becomes 10 times, time period becomes root 10 times. L becomes 25 times, time period becomes root 25 times, that is 5 times. So how will the graph of time period versus L will look like? We know that time period is proportional to L raised to the power of half. If we think of the graph, who grows faster? Sir, when length becomes double, time period becomes root 2 times. Length becomes triple, time period becomes root 3 times. So definitely the length grows faster than the time period. If the length grows faster than the time period, then the graph has to be something like this. Here the length is growing at a faster rate compared to the time period. Let's see more usage. We know that the electric field produced by an infinitely non-conducting sheet having a charge per unit area sigma is given by E equals to sigma by 2 epsilon. If I ask you what will be the graph of electric field versus the distance from the sheet, what will be the diagram like? So here you can see that electric field due to an infinitely large non-conducting charge sheet which is given by sigma by 2 epsilon naught is independent of R. So as E is independent of R, electric field intensity do not change with the distance from the sheet. So if we draw the graph of E versus R, what we will get? A straight line, because whether you keep on increasing the separation or keep on decreasing it, the strength of electric field remains the same. So you get a straight line graph. The last one here, electric field due to an infinitely long line charge having charge per unit length lambda at distance r from the line charge is given by 2k lambda by r. What will be the graph of electric field versus the distance from the line charge? So here you can say that electric field is inversely proportional to r. So when the distance from the line charge becomes double, electric field intensity becomes half, the distance becomes triple, it becomes 1/3, distance becomes 10 times, the electric field strength becomes 1 by 10 times. So how will the graph look like? So as R becomes infinity, electric field strength tends to 0. As R increases, electric field strength decreases. As R tends to 0, electric field strength tends to infinite. So the graph is like this. Actually, this particular graph is called rectangular hyperbola. When a quantity y is inversely proportional to quantity x, the type of graph we get is called rectangular hyperbola. Moving on. Now let's talk about binomial approximation. This is a very useful tool and is used in many chapters of physics, and it will be useful in solving many questions. So let's focus. If the magnitude of x is less than 1, then 1 plus x raised to the power of n can be approximated to 1 plus nx. 1 plus x raised to the power of n can be approximated to 1 plus nx. Now let's think of a case. If you have got 7 square, you can write it as 1 plus 6 whole square. From the binomial approximation we have just learned, 1 plus x raised to the power of n can be approximated to 1 plus nx. So you can say this is nearly equals to 1 plus, bring the power n in front, 2 times of 6. So that becomes nothing but 1 plus 12, and that is equals to 13. Hence 7 square is nearly equal to 13. This is wrong. You shouldn't do it. Why? Binomial approximation works really good only when the x has got magnitude less than 1. So first thing first, the binomial approximation tells me for the magnitude of x less than 1, 1 plus x raised to the power of n can be approximated to be equal to 1 plus nx. So let's take some example. How to find 1.002 whole cube. If this calculation comes somewhere in your examination, you can't do 1.002 into 1.002 into 1.002. That will be a time-taking process. So what to do? Use the binomial approximation. You can say that 1.002 whole cube can be written as 1 plus 0.002 whole cube. As 0.002 has very small magnitude compared to 1, we can use the binomial approximation. This doesn't give you exact answer. It's an approximation. So you will say 1 plus 0.002 whole cube can be approximately said to be equals to 1 plus the power n, which is 3 times 0.002. So that becomes 1 plus 0.006, and that is nothing but 1.006. Hence, 1.002 whole cube can be said to be approximately equal to 1.006. If you don't have faith, take out your calculator and calculate this, and you will find this to be a really good approximation. Next example. If you need to find 0.998 raised to power of 5, I am very sure you are not going to multiply the same number 5 times 0.998 into 0.998 into 0.998 and so on. So what we are going to do here, we are going to use binomial approximation. We can write 0.998 as 1 minus 0.002. We can write 0.998 as 1 minus 0.002. Then we can use the binomial approximation. For the magnitude of x less than 1, you can use the binomial approximation. So you can write this as 1 plus minus 0.002 raised to power of 5. Bring the n and multiply it with x. So you get 1 plus 5 times minus 0.002. That becomes 1 minus 0.01. Do 0.002 into 5. What you get is 0.01. So 1 minus 0.01 gives me 0.99. Take out your calculator, calculate it, and you will find that this is a really good approximation as the magnitude of x is less than 1. For the sake of understanding, let's take one more example. What is 1 upon 1.002 whole cube? How to find it? 1 upon 1.002 whole cube. 1 upon 1.002 whole cube. So, you can write this thing as 1.002 raised to power of minus 3. Yes, sir. And then you can write this 1.002 as 1 plus 0.002 raised to power of minus 3. As the magnitude of x is less than 1, you can use the binomial approximation. Once again, binomial approximation do not give you exact answer, it gives you an approximate result. So, for the magnitude of x less than 1, you can bring the power in front, and what you get is 1 plus minus 3 times 0.002. So that gives you 1 minus 0.006, and 1 minus 0.006 will be nothing but 0.994. Easy to calculate using binomial approximation. So now let's move on and talk about straight line. Let's take an example to understand straight line first. Let's say you have 100 rupees with you, and a person X, can be your uncle or someone, and a person X gives you 10 rupees per day. How much money you will have after 1 day? So you'll say, I already have 100 rupees and somebody gives me 10 rupees per day. How much money I will have after 1 day? So you'll say, after 1 day I will have 100 plus 10, that is 110 rupees. How much money you will have after 2 days? So sir, after 2 days I already had 100. Each day the person is giving me 10 rupees. So in 2 days the person will give me 20 rupees. So I will have 100 plus 20, that is 120 rupees. After 3 days, sir, now it's boring. I already have 100 rupees and the person gives me 10 rupees per day. So in 3 days the person will give me 30 rupees. So I will finally have 130 rupees. How much money you will have after n days? So sir, I already had 100 and in n days the person will give me n into 10 rupees. So what I will have is 10n plus 100 rupees. Now see here, what is the rate of growth of your money? What is the rate of growth of your money? How much does your money grow per day? It increases by 10. So the rate of growth of money per day is 10. Okay. What is this? 10n plus 100. So this is the amount of money that I have after n days. So can we write an equation that the money you have after n days equals to 10 into n plus 100. What is 10 here? The rate of increase of your money. And what is 100 here? The 100 is the money you had when the number of days were 0. The money you initially had. Now this is in crux the equation of straight line. Now let's talk a little bit more to understand it. We know that the money you have after n days is 10n plus 100. After 1 day you had 110, after 2 days 120, after 3 days 130, after n days 10n plus 100. If we try to plot the graph, what will the graph look like? So if we plot the graph of money versus number of days, when the number of days is 0, you have 100. When the number of days is 1, you have 110. When the number of days is 2, you have 120. When the number of days is 3, you have 130, and so on. So the graph will be something like this. Now this graph is the graph of straight line. Now this graph is a straight line. So the general equation of straight line is given by y equals to mx plus c. Y equals to mx plus c. Now see here, I have plotted m on the y-axis and n on the x-axis, and there is a constant c. What is c? The c is the value of y when x is 0. What? Once more. C is the value of y when x is 0. If you substitute here x equals to 0, what do you get? Y equals to c. So c is the value of y when x is 0. C is the value of y when x is 0. Okay. Let's understand more. So, in the general equation of straight line, y equals to mx plus c. What is m and what is c? So c is the value of y when x is 0. That is called the y-intercept. So what is the meaning of y-intercept? The place where the graph cuts the y-axis. The place where the graph cuts the y-axis is called y-intercept and is denoted by the letter c. C is the value of y when x becomes 0. Next, what is m? M is called slope, and slope is the tan of the angle made by the line with the positive x-axis. So if you have a line making an angle of 30 degree with the positive x-axis, you say the slope of this line is tan 30 degree, and we know that tan 30 degree is 1 by root 3. So the slope of this line comes out to be 1 by root 3. So in the equation of straight line, we have got two things. The general equation of straight line goes like y equals to mx plus c. What is m? Slope of the line. And what is c? The y-intercept. Now let's learn how to write the equation of straight line. If you have this straight line, how will you write its equation? I need just two parameters. We know that y equals to mx plus c. So as to write the equation of straight line, I just need two parameters, the slope and the y-intercept. From this graph, I can tell what is the slope and what is the y-intercept. So we can see that the slope is tan 30 degree and tan 30 degree is 1 by root 3. So I already know m. And from the graph, we can see that the y-intercept is 2. As the slope is 1 by root 3 and the y-intercept is 2, we can simply write the equation as y equals to 1 by root 3 x plus 2, just substituting the value of m and c. So multiply each term with root 3. What you get is root 3y equals to x plus 2 root 3. So let's practice one more example. Sure. Let's write the equation of line shown by this. So just looking at this straight line, we can say that the y-intercept for this line is 4. And what is the slope of this line? So we can say that the slope of this line is tan 135. And tan 135 is also equals to minus tan 45. Tan 45 is 1. So the slope of this line will be minus 1. So from the general equation of straight line y equals to mx plus c, now we know that the slope is minus 1 and the c is 4. We know that the equation of line will be y equals to minus x plus 4. So writing equation of straight line is an easy thing. Let's practice one more example. Let's write the equation of this line. So now you know that you just need two parameters, the slope and the y-intercept. So you will say here the y-intercept is minus 2 and the slope is tan 60 and tan 60 is root 3. Hence, the equation equals to y equals to mx plus c. As c is minus 2, we have written here minus 2. Now, shortest distance of a point on a line from origin. This becomes useful in some later chapter where we need to find the shortest distance. So let's say we have a line given by y equals to mx plus c. There are infinite points on this line. The simple question is, which point on this line is closest to the origin? So sir, as to find the point on this line which is closest to origin, so that will be this point. How will you find this point? So I will drop a perpendicular from origin on this line, and the point where it cuts the line, that point will be the closest point. So let's say there is this point P on the line which is closest to the origin, and let's say the distance of this point P from the origin is T. So what we are going to learn now, how to find this D if you have the equation of line as y equals to mx plus c. Let's see how it's done. So let's say we have this line having equation y equals to mx plus c, and we need to find the shortest distance D. Look into this right angle triangle. As this angle is theta, this angle right here will be how much? So you'll say, sir, this angle will be 90 minus theta. Now, what I want you to focus is on this right angle triangle again. So if you visualize this right angle triangle, what is the length of its hypotenuse? So you will say, sir, the length of its hypotenuse is C. What is this angle right here? So you will say this angle is 90 minus theta. So how will you write this distance D? You will say, sir, looking into this right angle triangle, C is the hypotenuse and D is the perpendicular for the angle 90 minus theta. As D is the perpendicular for the angle 90 minus theta, we can say that D has to be equal to C sine 90 minus theta, using what we learned how to take the components earlier. So D equals to C sine 90 minus theta. And we know that sine of 90 minus theta is cos theta. So D is nothing but C cos theta. So sir, let's say we have established that the point on the line which is closest to origin is at distance C cos theta. How to find C cos theta? From the equation of straight line, you already know what is the y-intercept. But sir, how to get cos theta? You don't know what is cos theta, but you know what is tan theta. Tan theta equals to m. So if you know that tan theta is m, you can find out cos theta. Tan theta equals to m. It means that perpendicular upon base equals to m. So think of a right angle triangle for which the perpendicular to base ratio is m. If you think of such a right angle triangle, let's say the perpendicular is m and the base is 1. If the perpendicular is m and the base is 1, then the length of hypotenuse has to be under root of 1 plus m square. So you have drawn a triangle, a right angle triangle for which tan theta is m. If tan theta is m, what will be the value of cos theta? The cos theta has to be base upon hypotenuse. So if tan theta equals to m, then the value of cos theta is 1 upon under root of 1 plus m square. Now, since you know C and you know cos theta, you know what is the value of D. So you can say that D equals to C into cos theta, which is 1 upon under root of 1 plus m square. Hence, D is nothing but C upon under root of 1 plus m square. Let's see an example to understand this further. Determine the distance of the point closest to origin on the line y equals to x plus 4. So from the equation of this line y equals to x plus 4, we know that the slope of the line is 1. So tan theta equals to 1. So theta equals to 45 degree. And the value of C, which is the y-intercept, is nothing but 4. Now, this is what the line will look like. We need to find the shortest distance. We have just learned that D equals to C upon under root of 1 plus m square. So as we know that D equals to C upon under root of 1 plus m square, substituting the value of C as 4 from the equation y equals to mx plus c, and substituting the value of m as 1, we get the shortest distance is 4 upon under root of 1 plus 1 square. That is 4 upon root 2, which is nothing but 2 root 2. So the point which is closest to the origin is at a distance of 2 root 2 from the origin. So the last important point which we are going to discuss in this leg is here. If two lines are perpendicular, then if the first line makes an angle theta with the x-axis, the angle made by the other line with the x-axis will be 90 plus theta. So if we consider the slope of these two lines, you will say that the slope of the two lines will be, say, m1, where the slope of first line will be nothing but tan theta, and the slope of second line, say m2, will be equals to tan of 90 plus theta. So what are you trying to establish here? So if two lines are perpendicular, then their slope will be tan theta and tan of 90 plus theta. Yes. You can write tan of 90 plus theta as minus cot theta. as tan of 90 plus theta can be written as minus cot theta. When you multiply the slope of these two lines, you get that the multiplication of their slope will be nothing but tan theta into minus cot theta. We know that cot and tan are reciprocal. So tan and cot get cancelled. So what you're left with is nothing but minus 1. So remember that if two lines are perpendicular, then the multiplication of their slope is minus 1. Let's say first line has got slope of 2 by 3. Then the slope of second line will be minus 3 by 2. The multiplication of their slope should be equal to minus 1. Hope you like this session. Stay tuned to Scomore.